All right, folks, welcome back. Let's dive in. There's my phone. Let's do some radical work. All right. First, just some practice with radicals. I'm thinking you guys could use the extra time and practice with these problems. I'll do a few examples here, then you do your set over there. I would focus on, as you guys are learning this, first just rewriting the problem to deal with where the exponent piece of that fraction is and where the root piece of that fraction is. So I'm going to put a square root with a 3200, and the top is my exponent. So that's telling me it's the 32 to the third power. And the 5 on the bottom is telling me the root. So it's being taken to the fifth root. Now, deal with the root first. Deal with this piece of it. Figure out if you can do 32 to the fifth root, because we don't want to take 32 to the third power. That's literally going to be probably in the tens or hundreds of thousands. We don't want to go there if we don't have to. So first I'm just going to think about 32 to the fifth root. So I'm going to think, what times itself, 5 of them equals 32. I'm going to check 2's, because I think that's the only number small enough that might work. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So it works out. The fifth root of 32 is just 2. And then don't forget about that 3. So really, all it's telling us to do is the fifth root of 32, and then I can do 2 to the third power. That's just 2 times 2 times 2. Don't forget that. It's not adding, and it's not 2 times 3. It's 3 2's multiplying, so we get 8. Right? Same thing with 125. I'm going to start by putting it under a root, and the root it's being taken to is the third. So cube, the cube root of 125, and the 2 is the exponent. Cube root of 125 is there 3 of something that multiplies to make 125. And when I think about it, there is. It's 5 times 5 times 5. Now, for anybody who would say, well, geez, Mr. A, how'd you know that off the top of your head? I don't know what the cube root of 125 is. Great call. Start here. You know it's got to be 3 of something. And similarly to when you do long division and you have to guess how many of a number fits into another, and then you have to multiply over on the side of the problem a few extra times to kind of find if your guesses are right, we'll do the same thing here. I'm going to start and maybe say, well, maybe it's 3. Let's try 3 times 3 times 3. That's 27. That's way too low. So it can't be that. So then I just keep guessing my way up. How about 4 times 4 times 4? Well, that's 16. And 16 times 4 is 64. Well, getting closer, but it's not the 4s either. And so you just work your way up with guessing, and it turns out to be 5. 5 times 5 times 5 is it. So the cube root of 125 is 5. And now don't forget to square. And there you go, 25. All right. I'll take the root of 64. What root? Third root. I think we just figured that out last problem. It was 4 times 4 times 4 gives us 64. And then we're going to square that answer. So the cube root of the 64 is 4. And then we're told to square it, which remember is 4 times 4 for 16. You try your set. Go. All right, let's see if you were doing it correct. 64. And if there's a 1 on top for your exponent, you don't have to do any exponent work. So it's just 64. You're taking the square root. What times itself is 64? And that's 8. 8 times 8 equals 64. All right, 16, and we want the fourth root being raised to the third power. 4 of what makes 16? Well, that has to be 2. So the fourth root of 16 is 2. Now I can apply my third power exponent. 2 times 2 times 2. Final answer, 8. All right, 27. Taking that to the third root and the fourth power. What times itself? 3 of them is 27. That's going to be the number 3 raised to the fourth power. Side note, for anybody who's just sitting here watching right now, pencil's not on paper, you're not actually doing these, or you are kind of going along and just copying as I go, you are not actually learning right now. You are passively engaging. This is not a YouTube video. This is not a television show. If you are not stopping and thinking and working this out on your own, you're not actually doing any learning. Just that out there. Okay, perfect squares. Remember these? We did them the other day. Why don't you... Oh, and I didn't even fill them in. Bonehead. Why don't you fill these in? Shoot. There you go. Now, fill those in. What is the square root of 25 or 16 or 100? These are all perfect squares, meaning they'll come out evenly. And remember, when you don't see anything, right there, it's always the invisible 2. Go ahead and fill these in. Go. All right, let's check. Square root of 25 is 5. 16 is 4. 100, 10. 4 is 2. Square root of 1 is 1, because 1 times itself is still 1. 49 square root 7. 64 square root 8. 81 square root 9. 36 square root is 6. And the 9's square root is 3. Okay? Those are important to have memorized. You're going to be using those in upcoming problems here. Okay, enough. Whoops. Let's talk about what we're doing today. And what we're doing today involves factoring. You guys remember factoring? Remember those factoring trees in about 6th grade? If not, let's look at it right now. Factors, let's start with that. A factor is a value that multiplies. That is the key thing. Factors are all about multiplication, okay? So a factor is a value that multiplies to make the larger value. So if we talk about factors of 32, we're asking what times what makes 32, and we're breaking the 32 down into those two numbers. So we could say 8 and 4. You could have also said 16 and 2, and that's okay. It'll work out the same way either way you go. So you don't need to have your tree set up the same way my tree looks. We'll get to the same set of answers at the bottom. Because now we continue, and we break down that 8 into its factors, which is 4 and a 2. We can break that 4 down into its factors, which is 2 times 2. And then we keep looking until we get to this point. We keep breaking them down until we get here. And we've got 2, 2, 2. Well, 2 is a prime number. There's nothing times itself that makes 2 except for 1 and that number itself. That's what a prime number is. And this doesn't give us anything new. We've already got that 2. We can't just relist it. And 1 times anything isn't actually a factor because it doesn't break the number down. So we stop once we get to the prime number. We stop here. 2 is as far as it goes. And there is one more 4 over here we got to break down. And so we see that 32 breaks down into the factors. If we go to the prime factorization, that means go all the way until you're done, until you can't break it down any further. And we have 1, 2, 3, 4, 5 2's. So it turns out you could just write 32 as 2 to the 5th power if you want. Those are equivalent. Okay, so that's the idea of breaking it down. Let's do it again with 60. We could think of 15 times 4. We could think of 6 times 10. But it doesn't matter because eventually the 15, the 4, the 6, the 10, they're all going to break down to those prime numbers. So where you start doesn't matter. So anytime you're stuck and you don't know what factors are for a number, if it's even, meaning the ones digit place is a 0, 2, 4, 6, or 8, If you were stuck and not sure what factors are, you can always just do 2 times half of the number. Any even number always has a factor of 2. And again, if I'm stuck and I don't know what's inside of a 30 for factors, I can just do 2 times half of it, which is 15. Now, 5 is not an even number, so there's no more 2's in there. I can't use that method. But you can get all of the 2's out and break it down if it's too big to start. And hopefully now we can see, 15 is just 3 times 5. And at that point, we're done. These are all prime factors. None of them break down into anything else, so the 60 is done. Okay, let's do a couple more just to be clear. 81, well, that's 9 times 9. And a 9 is a 3 times 3. So the prime factorization is just a whole bunch of 3's. We could even rewrite 81 as 3 to the 4th power. It's the exact same thing. It's equivalent. Last one, 45. We've got 9 times 5. And then 9 really breaks down to 3 times 3. So there we go. And by the way, these are all still valid factors as well. They don't have to be a prime number to be a factor. 9 and 9 are also factors of 81. 30 and 15 are also factors of 60. So you don't have to call it a prime to be a factor. They're all factors, but we need to get to this prime level for you guys to be good at what we're going to do today. All right, let's have you practice these yourself. Go ahead and break these guys down into a set of prime factors. Do those 3. Go. I gave you a couple more. Finish those up. Okay, I'm going to jump behind you. 42, I'm going to go 6, 7. 6 is a 2 times a 3, and we're done. 50, I know that's a 5 times 10. 5's prime, so now I break down the 10 into a 5, 2. And again, I'm done. 120, 12 times 10. Break down that 12 into a 6 and a 2, and the 6 goes into a 2 and a 3. 10 is a 5 and a 2. 64, 8, 8. Remember, your tree doesn't have to look like mine. All of your branch endings need to be the same as mine to get down to prime factoring. So however you did 42, you should have a 2, a 3, a 7. However you break down the 50, you should have a 5, and a 2. Okay? Then you know you've matched and done it correctly. 8 is a 4 and a 2. This 8 is also a 4 and a 2. Another thing. Notice I have to list both 8's. If 64 is 8 times 8, I need both 8's in the tree because each 8 breaks down into its own set of factors below that. And it's important to note that 64 has a total of 1, 2, 3, 4, 5, 6 2's in it. And notice those are all the branches at the end. All the endpoint branches, they all end in 2. So we could say 64 is really just 2 to the 6th power. Okay? And 36, we have a 6 and a 6, and each one of those breaks down into a 2 and a 3. So we could even say that 36 is 2 to the 2nd power times 3 to the 2nd power. All right, hopefully that's making sense because we're going to use concept with our radicals today. What if you guys need to simplify a radical, but they're not a perfect square? It's not 36 whose square root is 6, or it's not 49 when the square root is 7 like we just practiced. What do we do with 32? I talked to you a little bit the other day about approximation if you want to do a decimal. That's not what we're going to do today. We're still going to keep things exact, and we're doing our math concept with it. It's not an approximation from a calculator. We're going to break down that 32 and see what's inside of it. We've got a 16 times 2, and we break that down. That's 4 and 4. And we can break that down to 2 and 2 and 2 and 2. So we see that the 32 really, when we get down to the end, breaks down to 5 2s. And remember, what are we being asked for? When you don't see anything right here, that's the invisible 2. So it's asking for a square root. So since 32 is not a perfect square, it's not like 49, which is 7 times 7 and you're done. The answer is 7. What we can do is we can look at the list of all these factors inside the 32. And if we want a square root, we're allowed to take pairs of any number that match out of the 32. So what if we take this first group of 2's? We can take the square root of that. That's just a 4. Square root of 4 is 2. So we could pull that 2. So if we think of rewriting this 32 and just listing them out as all those 2's, that's just what a 32 is. It's just 2 to the 5th power. What if we rewrote it and said, okay, there's one pair of 2's, which make 4. 2 times 2 is 4. We can take the square root of 4, and the square root of 4 is 2. So we break them out of that radical jail because we could take the square root of those 2's. It's a 4. There's another pair of 2's. We can take their square root. 2 times 2 is 4 again. We can pull that out. Let's make this a little less messy for you. We can pull them out, and there's another 2 on the front. Now those are multiplying. We're not creating some new number like 22. We pulled 1 2 out from the first 4 inside the 32, which is 2 times 2. We pulled another factor of 2 out from the second 4 that's inside the 32. And there's still one more 2 left over, and he's got no one to pair with, so he's stuck under the radical. He can't get out. So it turns out that the way you can simplify 32 is you can rewrite it as 4 radical 2, okay? And an easy way to think about that is 32 is just 16 times 2, if you want to look at it that way. And we can take the square root of the 16, pull it out, it's 4. Nothing left with that 2 to pair up with. You can't take the square root of 2, so it stays underneath. So 32, the square root of 32, is exactly the same as saying 4 times the square root of 2. But it's simplified because we got as much of the number out from under the radical as possible. It's kind of like simplifying a fraction. You want to get as much of the number out as possible. We're looking to find any perfect squares that are inside the 32. And rather than try to factor it perfectly and see the perfect square, I would recommend just going down to your prime factors, and then you just count up any pairs of numbers, because 2 times 2, that is the perfect square 4. And the other 2 times 2, that's another perfect square. Then you don't have to worry about factoring correctly, because if you miss that 16 when you factor, you might be stuck. All right, let's try it again, and let's get some room. I'm going to move that radical 28 over here, because we just have way too much going on over here. Okay. I'm going to break down my 28 because it's not a perfect square. It's 4 times 7. And right there, there's our perfect square. Okay, so we could pull that out. But if you didn't happen to see it, you can also just keep going and break it down. So we end up with 2 times 2 times 7. So what can I take out? I can take any pairs out. And that's because this is asking for a square root. So I can take a pair of 2's out. 2 times 2 is 4. Square root of 4 is 2. Notice if I find 2 2's underneath, I only pull 1 2 out, because the 2 times 2 is really a 4, right? I'm taking the square root of 4 and I'm getting 2. Looking at it as 2 times 2 is just another way to look at it. 2 2's mean 1 on the front, and I keep going with anything else I can find, but I can't. 28 is 4 times 7, and that looks like a 1. Let's rewrite that guy. So all that's left underneath, I can't pull him out or do anything with him, is the 7. So I leave it. The square root of 28 simplifies to become 2. times the square root of 7. Because there was that perfect square 4 inside the 28, I can pull him out and make 2. The 7 is left underneath. He's stuck. Okay. I swear this stupid software is faulty. I gotta find a new dry erase app. Okay. Oh, your teacher's gonna start cursing in a minute. What? No, I don't even remember what I put. 24. Now, this is the exact same thing, except the root changed. We don't want a square root, we want a cube root, but it's the exact same process. Break down that 24 into 6 times 4. We just keep going. We just look for all the prime factors. And so we see right there, we've got a 2, a 3, a 2, a 2. But since we're taking a cube root, we need to have groups of 3 to pull something out. There they are, 2, 2, 2. If we want to put them back together, if that helps you think of it, 2 times 2 is 4 times 2 is 8. So 24, we could think of just 8 times 3. And the cube root of 8 is 2. So if it makes sense to you to think of the 8 and take his cube root to get that 2 out front, do that. If it makes sense to think of it as the 3 2's we factored out, that group of 3, when we take its cube root, becomes 1 2 out front. Either way, we go from 3 2's on the inside to 1 out front because we're taking a cube root. And then the guy that's left, he's got no one to pair with, is that 3. He's got to stay under that radical. And don't forget, it's a cube root, so rewrite the answer correctly as a cube root. So the cube root of 24 can be simplified to become 2 cube root times cube root 3. That 2 was able to be pulled out of the 24 because that was an 8, which is a cube root. And what's left is just the 3. All right? Let's just keep going to make sure you guys get this. I'll just pick some random number. How about if I pick like 56? We go with a little bigger number. And we say we want a 4th root. Let's see what happens. Well, 56, I don't know off the top of my head, so I'm going to do what I told you guys. It's an even number. So I'm going to go 2 times half, which is 28. And then a 28 I know is a 4 and 7. And a 4 is a 2 and a 2. So what I have left is a 2, a 2, a 2, and a 7. But I need 4 of something. Do I have 4 of anything? Hopefully you're saying, no you don't, Mr. A. I can't take a 4th root of 56 at all. There's no way to simplify it because there was no group of 4 of anything. So I can't do anything. 4th root 56 stays 4th root 56 because we don't have a group of 4 of something we can take out. All right, let's have you practice some of these. Let me get some for you real quick. All right, there's a set of 3 of them for you. Give those a shot, pause it, and turn it back on in a minute, see if you got them right. All right, let's try it. 20, I'm going to break down 4, 5. 4 is just 2 and 2. And since there's nothing written, it's a square root. I just need pairs of 2 of something to pull them out. There's a 2 times 2 is 4. I can pull that out as a single 2. All that was left was my 5. I can't get him out from underneath the radical. So it's just 2 radical 5. All right, second one, 42. Again, a square root. 6 times 7. And 6 is just 2 times 3. No pairs of anything. I can't do anything to simplify radical 42. Number 3. First, notice it's a cube root. We need 3 of something to pull it out. And let's start looking for those. 120 is 60 times 2. I can think of a 60 as a 30 times 2. 30 is a 15 times 2. Geez, lots of 2's. And 15 is 3 times 5. So I need groups of 3, and that's pretty obvious. I've got 1, 2, 3 2's. I can pull that group out. 3 2's are pulled out and become 1 2 on the front, okay? Because we're taking, hopefully that concept's kind of taking root with you guys, pun intended. I'm taking the root of those 3 2's. Okay, 2 times 2 times 2 is 8. So I'm saying, what is the calculation? Do the calculation where you shrink that 8 down to its third root, aka what number times itself 3 times makes 8. So the 2 2 2 is an 8 that I took the cube root of. Another way to say it is any group of 3 under the radical gets canceled out, and you have one of it on the outside. You took its cube root. All that's left over of my remaining factors is a 3 and a 5, which is 15. So I was able to cube root out a 2. What's left is a 15, and I've got 2 radical 15 there. All right? Hopefully this is making sense. Let's add variables to the mix, which is actually the easier part. Let's try with variables. Now notice x to the 5th is just 5x's. Okay, and there's nothing written, so we're looking for a square root, which means we need pairs of 2. So notice, it's like the number's already factored. There's no work to factor, because the variable is just a group, how many x's you have. So there's one group of x's that are able to be taken out. There's another group, so I'm going to be able to take, let's do it this way. This group of x's, when I take its square root, becomes an x on the outside. This group of x's, when I take its square root, becomes an x on the outside. This x is by himself. I can't take him out from under the radical, so he is stuck inside. And then what can you do if you have x times x? Hopefully you guys are saying, well, x times x is x squared. And so we end up with that. Notice the shortcut that we just undertook, or that we can take. We can create a shortcut from what we just did. It's a square root we're taking. So we're just looking for groups of 2 out of the 5. So I can take 2 groups of 2 out. Okay. One group of 2 is the first x, second group's the other one. And 2 times 2 is 4. We took 4 total x's out of the 5, leaving the 1. And when you take them out, remember you only take 1 out of each group. I took 2 groups of 2, so it makes those 2 x's. All right, let's do it again. It's probably easier if you watch. 3 p's. It's a square root if nothing's written, which means I can take a pair of p's out. That becomes 1 p on the front, and then 1 p is left inside. Do the exact same thing with the m's. 4 m's, it's a square root, so 2 of them and 2 of them. There's 2 groups of m that come out. There's 1 group of m. There's the other m that comes out, and if it's m and m, why not just write them together as a squared? And there's no m's left underneath, because you can take the square root of 4 of something. You're going to have 2 groups that come out and nothing left underneath. So that's it. It'll become pm squared times radical p. All right, let's try that last one. Cube root doesn't make it harder, just means we're looking for groups of 3 to take out. Okay, out of those 5 m's, we can take 1 group of 3 out. So there's 1 group of 3 for the m's. There's 2 left over. And 2 is not a group of 3, so they're stuck underneath. Do the same with the p's. 2 p's, that's all we got, but we need 3 to be able to pull a group out. It has to be 3. We don't have it. They stay underneath. And then we've got 8 y's. And we need groups of 3 for a cube root. There's 1 group of y we can take out, so I'll put a y out front, so those are taken. Another group of 3 y's gets taken out. We'll call it a y squared. That's our second group. And then there's 2 y's left over. They have to stay underneath. And there we go. My squared and times the root or the radical of m squared, p squared, y squared. And notice if it's a cube root, nothing will be left that's a 3 or higher on exponent. because they all came out. They have to get reduced down to 2 or less. Same thing on the first 2 problems. If I was trying to take a square root of something, nothing in the answer can be any higher than just a variable by itself. Because if it had an exponent 2, it can come out. Problem number 2, same thing. It was a square root, so nothing left underneath will have any root except 1. It has to be smaller than the root. Otherwise, it'd be able to come out. All right? You guys. All right, there you go. There's some practice problems. You try those 4. I'll come behind you in a minute. Go. All right, let's take a look. We got a square root. There's 5 p's. There's one group of 2 p's. Take their square root, they become 1 p on the outside. There's a second group of 2 p's. Take their square root, they become another p outside. That last piece stuck onto the radical, and the way we would write p is p squared, right? I mean, p times p is p squared. So there you go. Hopefully you guys are starting to get this idea without needing to draw all these out, because that's going to take a lot of time. It's great to get the concept, but we have to shift to being able to see it without. Let's try that on the next problem. It's a square root. There's 4 m's, so I can take, there's 2 groups of 2 m's. So there's 1, there's 2. Okay, I'll put those together in a minute. x3, I take one group of 2 out, which becomes an x out front. That pair of 2 cancels into 1x outside, and we're going to have to move this underneath. Let's do that. We're going to run out of room. And we've got one of those 3 x's gets left under the radical because he's got no one to pair with and take a square root. Then we've got our y's. We need to take one group of 2 y's, pull it out. Now there's 3 left. So we can take another group of 2 y's and pull it out. I'm just going to call it a y squared because I ran out of room. And there's 1 y left underneath. And then that pair of m's would also become an m squared. Okay, 2 m's is an m squared. X, y squared. And there's our radical xy, because we had, and you can see we had that odd number. 1x has to be left because it was x3. 1y has to be left because it was y5. And the even number, the rest, just paired up and pulled out. Okay, next one. Now we're doing cube roots. So out of that 5 p's, we can pull one group of 3 away from the p. So if I take one group of 3 away, there's 2 p's left over. And that group of 3 p's becomes a single p on the outside because we took the cube root of that p. Okay? The m's, there's only 2 of them, but we need 3. Can't do anything with 2 m's when you need cube roots, so we leave them. The x, there's 4x. We can take one group of 3 away from it. That 4th x is left. And that group of 3 x's, to pull it outside the radical, you take the cube root, so that 3 x's shrinks down to 1, and there you go. All right, last one. I kind of threw this one out to force you to start doing it without the drawing a little bit. Okay, we've got 12 x's, and we need a group of 9. So if we take a group of 9 away, we're left with 3 of those x's. That group of 9, when you pull it outside and take its 9th root, becomes that 1x. There was one group of 9. So you can think of the root as how many groups of that you pulled out. Okay, P18. That can become 2 groups of 9. All of the 18 disappear, so there's no p's left under the radical, and 2 groups of 9, 2 9th roots, that's going to leave 2 p's, or a p squared. Okay, y8, it's not quite enough. We need 9 of something to make a 9th root. We only have 8. So the y's are stuck underneath. All right, how'd you guys do? Hopefully that made sense to you, and that is not going to shrink down. All right, there you go. There's your set of practice problems. I am not going to stick around to write out solutions for you. I'll put them on the, I'll cover them on the video lesson tomorrow, so this video does not get extremely long. All right, see you guys.